In this content, we will examine the parts of the jets, the basic engineering behind it, the two powerful General Electric jet engine, how they work, the weapon system it carries that makes it a fighter attack aircraft, and most importantly, the basic principle of how a plane flies, and many more animated in 4K 3D animation. So kindly smash the subscribe and like button for more detailed content like these. F/A-18 Super Hornet got its name with the designation F, stands for fighter and A stands for attack. The Super Hornet was designed and built by McDonnell Douglas and first flew in the year 1995. After the merger of McDonnell Douglas and Boeing, the two giants of the military industry, it joined the U.S. Navy's fleet, replacing the aging Grumman F-14 Tomcat, which in its right was a legend, but had to retire in 2006. The Super Hornet was re-engineered from the original Hornet, which was 20% smaller. It has oval air intakes, while the Super Hornet has rectangular intake ramp. This is one of the fastest methods to distinguish between the Hornet and the Super Hornet, but for now it will be exploring only the single-seater F/A-18E Super Hornet. Now the Super Hornet is a bigger jet, with a length of 18.31 meter, and it was also decided to increase its wingspan to around 13.62 meter. This is much bigger as compared to its predecessor, the Hornet. This gives it a 20% increase in size, increasing its weight to a massive 32,081 pound or 14,552 kg. When it is equipped as a fighter, it has a gross weight of 47,000 pound or 21,320 kg. Let us look at the parts of the jet, starting from the front. This is what is called the radome or integrated four-body tip cap, which houses the powerful radar inside, called the APG-79 or Active Electronically Scanned Array. Now these tiny ports might look harmless, but the middle is a gun port inside it, houses a monstrous beast, the 20mm M61 rotary cannon that was devastating for the enemy, which we will come back to it later. This is the in-flight refueling probe called IFR, which doubles the F/A-18 Super Hornet range indirectly. Moving back, we have the impact-tolerant polycarbonate windscreen with titanium hold bars. This helps protect the pilot from blast fragments. This is the VHF or UHF L-band antenna. They use very high-frequency VHF and ultra-high-frequency UHF signals for two-way radio. Moving back, we have the ECS-RAM air exhaust or environmental control system, which provides temperature and pressure-regulated air for heating. These twin valves provide air to the primary heat exchanger. There are a number of self-sealing fuel tanks in this aircraft. Fuel tank 1 is situated right behind the pilot's seat, followed by the fuel tank 2, which supplies fuel to the left engine. Fuel tank 3 supplies fuel to the right engine. Fuel tank 4 sits right in the middle of the aircraft, along with two fuselage vent tanks. On the wings are two massive fuel tanks on each side, also known as wing fuel tank. Two more vertical fin vent tanks are located on the fins of the aircraft. To increase its range, the F/A-18 Super Hornets carry 2 to 3 additional external fuel tanks of 480 gallons, or 1,800 liters each. Altogether, it can carry a massive 29,000 pound or 13,000 kg of fuel on the aircraft, which is approximately 4,500 US gallons. Imagine this amount of fuel. It can fill up to 264 numbers of Jeep gas tank. All of this is because of these two powerful engines. This is the General Electric F414G E400, which has a 22,000 pound class after burning turbofan engine. Now, let us see how this works. Air is sucked from both the rectangular intake ramp. Fuel is sprayed into a segment of the jet pipe, where it mixes with the exhaust gas. It is then ignited, causing a second stage of combustion. To conserve jet fuel, the afterburner is used only in short bursts during takeoff, altitude climb, or combat maneuvers. The exhaust nozzle is made up of petals and is engineered in such a way that it reduces or widens its gap. This is to reduce the stress on the turbofan engines when it is in full afterburning mode. Now, let us look into what makes a jet maneuver those awesome dogfights. But before diving into the details, let us look at the parts of the wings. Situated just above the two turbofan engines are two rudders attached to the tails. Moving down are the two huge elevators. This is the aileron. Moving forward, this is the flaps and slats, which are attached to both the wings. If the flaps and slats are opened, it boosts the downwash as well as increasing the lift of the jet, extremely useful during dogfights. The ailerons have the ability to move up and down, and it is for this reason that the lifting force can be reduced and, correspondingly, increase. This is the elevators, which can be adjusted to make the aircraft go up or down, while the rudders help the aircraft moves left or right, also known as yaw. This is the cockpit of the Super Hornet, but for now, to learn how to fly a plane, we will be looking at only the controller stick, the throttle, the flaps, and the pedals. Now, let us look at the basics of how a fighter flies in relation to the controller surfaces. When the pilot makes a movement using the control stick to the left aileron is deflected up, causing a downward force, while the right aileron is deflected down, causing an upward force, resulting the plane to roll to the left. When the pilot moves the control stick to the right aileron is deflected up, causing a downward force, while the left aileron is deflected down, causing an upward force, resulting the plane to roll to the right. If the pilot pulls back on the control stick, the elevator will rise, providing a force that will push the airplane's tail down, causing the nose to pitch up and the plane to begin rising. Now, let us look at how the rudder works. As the pilot pulls on one of the rudder pedals, the rudder, which is controlled by the rudder pedals, is joined to the back end of the vertical stabilizer. As air travels around the deflected rudder, a force is applied, which causes the plane to yaw. Simply pressing the left rudder pedal causes the plane's nose to drift to the left, and pressing the right pedal, the nose of the plane will turn to right. Enough with the basic flying controls, let us move to the armaments, also called weapons system, of the F-18 Super Hornet. This cannot be called a fighter attack jet if we do not talk about the weapons on board, so to make it easy to understand, the F-18 may be easily converted to perform either for an air-to-air combat or a close air support aircraft, which makes it a versatile weapon. For an air-to-air combat operation, it carries the AIM-9 Sidewinder, which is a supersonic, heat-seeking, air-to-air missile. It has a high explosive warhead and an infrared heat-seeking guidance system, with an operational range of 0.6 to 22 miles or 1 to 35.4 km, with a maximum speed of 2.5 Mach. This is the AIM-7 Sparrow, which is a medium-range, semi-active radar homing air-to-air missile with an operational range of 14 miles to 53 miles depending on variants. It has a maximum speed of 2.5 to 4 Mach depending on variants. This is the AIM-120. Advanced Medium-Range Air-to-Air Missile, or AMRAAM, is a beyond visual range air-to-air missile, capable of all-weather day and night operations with an operational range of 55 to 100 kilometers, again depending on the variant, and a maximum speed of Mach 4 or 4,000 kilometers per hour. For close air support, the Super Hornet switches to a JDAM bombs. The Joint Direct Attack Munition, called JDAM, is an all-weather precision-guided munitions guidance kit. This is the AGM-65 missile, which is a close air support air-to-ground missile, is capable of hitting armor, air defenses, ships, ground transports, and fuel storage sites, with a maximum speed of 700 miles per hour. For long-range precision strike, it uses the Paveway laser-guided bombs, the GBU-12, which is an aerial laser-guided bomb with a nose-mounted laser seeker and fins for navigation. Based on the Mk-82 500-pound or 227 general-purpose bomb. Let's take a closer look at the cannon. The Hornet is armed with the M61A2 Vulcan, a powerful 20 mm, 6-barrel rotary gun. The M61A2 is a hydraulically operated, electrically fired, rotary-action cannon mounted inside the craft's nose. The operators have the option of firing at a pace of 4,000 or 6,000 rounds per minute. The gun is used to engage enemy aircraft and ground targets with 20 mm, M50 or PGU series electrically primed rounds. This cannon has a range of 2,000 feet or 600 meters. The future of the Super Hornet is being upgraded to the latest Block 3, as well as the F-18 Growler, giving it life for the next decade to come, all because of the high cost of the F-35 Lightning. So check out how an F-35 Lightning works in 4K 3D animation. Our small channel needs your support,